Welcome back to TechTrouble Solved. Today we are breaking down one of the most common and important array problems, move zeros from LeetCode. By the end of this video, you will understand the logic deeply enough to apply it to many similar array problems. Let's start with the problem statement. You are given an integer array. The goal is simple: move all zeros to the end, while keeping the order of all non-zero elements the same. And we must do this in place, meaning no extra array is allowed. For example, this input becomes this output. The non-zero items stay in order and all zeros shift to the end. Most beginners try this approach first. Copy all the non-zero elements into a new array and then add zeros at the end. But this uses extra memory, which is not allowed in the real problem, and in interviews they expect something more optimal. So let's find a better way. Here is the key idea behind the optimal solution. We use two pointers. Pointer I scans through every element. Pointer last non-zero tracks where the next non-zero element should be placed. Whenever noms I not equal to 0, we swap it with noms last non-zero element and then move last non-zero index forward. This builds a clean block of non-zero elements at the front. Let's walk through this step by step. Step 1. I starts at index 0 and last non-zero is also 0. The value is 0, so we simply move on. In step 2, I moves to index 1. Here the value is 1, a non-zero number, so we swap it into the last non-zero position. The array now becomes 1 0 0 3 12 and we move last non-zero to index 1. Continuing the dry run, at index 2 the value is 0, so there is nothing to do in the step 3. At index 3 the value is 3, another non-zero, so we swap it with the element at last non-zero, which is at index 1. Now the array becomes 1 3 0 0 12 and we move the last non-zero to index 2 in the step 4. Now at step 5 I is at index 4 and the value is 12, another non-zero, so we swap it with the element at last non-zero, which is at index 2. Now the final array becomes 1 3 12 0 0, so this gives us the correct final structure. By the end of the scan, all non-zero elements are in front and all zeros naturally shift to the back. One great thing about this approach is that it handles edge cases beautifully. If the array has all zeros, nothing changes. If the array has no zeros, everything stays as it is. And if zeros appear at the front, the non-zero values simply get pulled forward. We don't need to write any special conditions for these cases. The two-pointer logic just works. Here is the entire logic in simple pseudocode. We start with last non-zero equal to 0, then we loop through the array from left to right. Whenever we find a non-zero element, we swap it with the element at last non-zero and then increment last non-zero. That's the whole idea. Now let's translate this directly into Python. Let's go through the problem statement once again. Given an integer array nums, move all zeros to the end of it while maintaining the relative order of the non-zero elements. Note that you must do this in place without making a copy of the array. So input is nums 0 1 0 3 12 and output is 1, 3, 12, 0, 0. Another example, nums I, this is all zeros and output is also all zeros. Constraints, nums length should be less than 10 to the power 4 and nums I is minus 2 to the power 31 to 2 to the power 31 minus 1. This basically means every element nums I is just a normal integer. It won't be extremely big or extremely small. It fits in a standard computer integer. Okay, so now as per our logic, we will define last non-zero as 0. Now we will loop through the entire array and check if any element is non-zero. So if element is non-zero at nums I, then we will swap it with nums at last non-zero. So this is our entire logic. We are just swapping the elements nums I and num slash non-zero when it's a non-zero element, and we no need to check if the element is 0 since zeros will move at the end by default with this logic. Now let's run it. Now let's submit. So this is the cleanest and most efficient version of the solution. One loop, 2 pointers and in-place updates. This is exactly what you should submit on LeetCode and exactly what interviewers expect. Now let's move back to the slide. To summarize, the time complexity is O of n. We scan the array once. The space complexity is O of 1. We only use 2 pointer variables. So the key ideas: single pass, in-place swaps, zeros automatically move to the end, order of non-zero elements is preserved. A very elegant 2-pointer solution. Thank you so much for watching. If this explanation helped you, make sure to like the video and subscribe for more Python and DSA tutorials. Comment below if you want me to break down any other LeetCode problem. I would love to make it for you. See you in the next one.